Hi students, in this video I'll be going through the 2022 GC O-Level Additional Mathematics Paper 1 question A. Alright, so let's read the question. So the diagram shows the curve y equals to 3 square root x and the line 4y equals to 3x plus k, where k is a constant. Okay, so the line intersects the curve at the points P and Q. So in the case where k is equals to 9, find the coordinates of P and Q. So we know that whenever we have a question that requires us to find the points of intersection between a line and a curve, what we need to do is we need to solve the two equations simultaneously, and then we should be able to find the coordinates of the intersection point. Right, so that's what we're going to do for this question. Okay, so the equation of the curve is y equals to 3 square root x. Okay, so let's call this equation 1. Okay, the line is 4y equals to 3x plus k. Okay, but for this question, k is equals to 9, right? Okay, so let's replace the k with 9. So they say that k equals to 9. Okay, so let's replace it with 9. Okay, so all we need to do now, we will just substitute equation 1 into equation 2. Right, so let's do that. So we will substitute 1 into 2. Okay, so we will get 4 times 3 square root x equals to 3 times x plus 9. So we will get 12 square root x equals to 3x plus 9. Okay, so at this point in time, what you need to do is you need to pause for a while and think about what's the way that you want to proceed with this question. So there's a square root x over here. So we are unfamiliar with solving an equation whereby there's square root x. Okay, so one way to get rid of the square root x would be to square both sides, right? Okay, so one approach that you can take would be to square both sides. Okay, because if you square the left side, it would just be 12 square, which is 144. Then square root x, you square, you get x. Okay, then of course the right side you will just go ahead and expand it, all right? Okay, but for today, okay, so you actually can use this method to solve the question. Okay, but for today, I want to introduce another method or just discuss another method which is slightly easier, okay, for you to solve. Okay, so we are unfamiliar with solving an equation whereby there is square root x. So what we can do is we can try to introduce a substitution to sub away this square root x. Okay, so what I'll do is, okay, you should be able to deduce okay, that x can actually be written as square root x squared, right? Okay, so once we have turned it into this form, then we can introduce a substitution, and you will realize that after doing the substitution, this equation will actually just become a normal quadratic equation, which we are very familiar at solving already. All right, so I'm going to let z be equals to square root x. Okay, so I'm not going to use y because y is already a variable that is being used here. So I'll use z instead. Okay, so once we let x equals to z equals to square root x, so what we will have will be 12z equals to 3z squared plus 9. So you can see that now what we have is just a simple quadratic equation, which we are familiar with solving. Okay, so we'll bring everything to one side. So we'll get this. So I'll bring the 12z to the right side, but I'll write everything on the left side. Okay, so before we continue solving, we can see that all the three coefficients are multiples of 3. So we can actually divide by 3 first. Okay, so divide by 3. Okay, then after that, we can just go ahead and factorize and solve. Okay, so we'll get z here, minus 1, minus 3. Okay, so this one not too difficult to factorize. So what we have is either z minus 1 is 0 or z minus 3 equals to 0. So z will be equals to 1 or z equals to 3. Okay, but remember that we are not solving for x in z in this question. What we want is to solve for x and then subsequently find y to get the coordinates, right, of p and q. Okay, so we should replace the z back with square root x. So square root x equals to 1. Okay, so we'll square both sides. X will be 1 square, which will give us just 1. Okay, Then on this side, we will have square x equals to 3. So x will be 3 square, which will give us 9. Okay, then all we need to do is take the 1 and sub into equation 1. Okay, it'll be easier to use equation 1, right? Okay, so y will be 3 square root 1. So that will give us 3. And then over here, y will be 3 square root 9. So square root 9 is 3. 3 times 3 will give us 9. Okay, so from here we can see that point P, okay, one of the coordinates is 1, 3, the other one is 9, 9. So quite obviously P is the 1, 3 and Q is the 9, 9, right? So don't write wrongly. So therefore P equals to 1, 3 and Q equals to 9, 9. Alright, so not too difficult of a question. Okay, but do study this part a bit, the part where I introduce a substitution. Okay, so you should be able to recognize that x can be written as square root x squared. Okay, after that, you can introduce a substitution, z equals to square x, and then after that, you will be able to turn it into a normal quadratic equation already. Alright. Okay, so let's take a look at part 2 of the question. Okay, so now part 2, they say that in the case where the line, okay, so for part 2, k is no longer 9, k is another value. Okay, in the case where the line is tangent to the curve, find the value of k. Okay, so if you recall, in order for the line to be tangent to the curve, the line must only touch the curve at one point. Okay, so in this case, this line is going to shift upwards, and then it's going to touch the curve something like this. Okay, so it's going to shift outwards and touch the curve something like this. Okay, so it's going to be parallel. Okay, the gradient is going to be the same. Okay, but now it's just going to touch at this one point. Okay, so now they are saying if the line is like this, right, tangent to the curve, then what must this value of k be? Alright. Okay, so same thing, the line and the curve intersects at this one point over here. So when we should still be able to try to solve the two equations simultaneously. But then now instead of getting two answers, we should be expecting to just get one answer, right? Okay, so let's just proceed with this question first, and then later on we see once we reach a certain point, how we can move further forward and then solve the question, right? Okay, so same thing, we try to solve simultaneously. So y equals to 3 square root x. Okay, once again, we let this be equation 1. Okay. Okay, then y equals to 4y equals to 3x plus k. This will be equation 2. Okay, so now what they want us to do is to find the value of k, right? Okay, so same thing, we're going to substitute 1 into 2. Okay, so that will give us 4 3 root x equals to 3x plus k. Okay, then 12 root x equals to 3x plus k. Right, so I'm going to do the same thing, introduce the substitution. Okay, so let z equals to square root x. Okay, so we will get 12z equals to 3z squared plus k. Okay, so now this is also just a quadratic equation. Okay, we have x to the power, z to the power of 2 terms, a z term and a constant term. Okay, so same thing, going to bring everything to one side. Okay, so over here. Okay, so now what we have is just a quadratic equation, right? So how many answers are we expecting to get? Okay, since the line is tangent to the curve, we should just expect to get one answer, right? Okay, one solution. Okay, but in the context of a quadratic equation, when you have a quadratic equation equals to 0, okay, one solution also means, if you recall, that this quadratic equation will have real and equal roots. Real and equal roots. Okay, so now, do you still recall now? Okay, we are talking about the discriminant, right? Okay, so now we need to relate it to what we learned in the chapter on discriminant. Okay, if a quadratic equation has real and equal roots, then the discriminant has to be equals to 0. Okay, so the discriminant b squared minus 4ac will be equals to 0. Okay, so what we can write is, since the line is tangent to the curve, okay, the above equation has real and equal roots. Okay, so it has real and equal roots. So b squared minus 4ac is equals to 0. Okay, so b squared minus 4ac is the discriminant. Okay, so b will be this negative 12 over here minus 4. Okay, a will be a 3, right? Okay, so this is b, this is a, so a is 3, and then the k will be the c. Okay, so b squared minus 4ac equals to 0. So all we need to do is just to solve this simple equation, and we'll be able to find the value of k. So over here, we get 144 minus 12k equals to 0. So minus 12k equals to negative 144. So k will be equals to 12. Okay. Okay, so this particular question, okay, pertains to two different concepts. Okay, so one is the concept of the solving simultaneous equation to find the intersection point. So now we know that for a line when it's tangent to the curve, there will only be one intersection point. So when we try to solve it, we should be expecting only one answer. Okay, and the context of a quadratic equation like this, okay, once we arrive here, it means that this quadratic equation has a real and equal roots. And we know that when a quadratic equation has real and equal roots, then its discriminant will be equals to 0, right? Okay, so I'll just, I've actually plotted this using Desmos already, so we can go over and take a look at that one. Okay, so share. Okay, so you can see y equals to 3 root x is the red curve, okay, the red curve over here. And then we found k to be 12, right, for the answer. So 4y equals to 3x plus 12. Then the blue line, okay, is tangent to the curve, right? So you can see that if I were to change the value of k to other values, right, then it is not going to be a tangent anymore. See, now it cuts at 2 points. Okay, so if I change to other values, it's not going to be, okay. And then if you recall, 9 okay, was the value of k that they told us to substitute in part 1, right? Okay, and then we got the points of intersection to be 1, 3, and 9, 9. So you can see over here, you have your 1, 3, and then you have your 9, 9, right? Okay, so this is what the question is all about, right?